Alright, this video is just going to be some practice and review. So you're going to try the problems and then you're going to follow along with the solutions if you didn't get it. Here we go. Okay, so write the linear function that has the indicated function values. What does that mean? That means your answer is a function because you are trying to write a linear function. If it's linear, what does that mean? Linear line. So you're trying to write the function of a line. You need to know what this notation means. What is that telling us about the function? Pause the video. Find that function. Unpause when you're ready to check your work. Okay, so let's look at this. If we're trying to write the equation of a line, then we need a slope. So I find the slope using the given information. And I get that my slope is 3/4. So now I use my slope and a point to write the equation of a line. Since that is the information that I have, the easiest way to write the answer is in point-slope form. It is called point-slope form because we use a point and the slope. So either the green or the purple would be correct answers in point-slope form. So y plus 15/2 equals 3/4 times the quantity x minus 2/3. Or y plus 11 equals 3/4 times the quantity x plus 4. Again, both of those are correct in point-slope form. For those of you that are sticklers for the slope-intercept form, we could also do that, and we end up with y equals 3/4 x minus 8. Pay attention to, on an assessment, if I ask you for a specific form, I expect you to write your answer in that form. So you need to know what these are. Next, I want you to find the coordinates on the graph of a function f if the given point is on the graph and the function is either even or odd. So this is like the example we did before. Pause the video, write down your answers, unpause when you're ready to check your work. Okay, so if we have some function that has the point -10, 21/3, and that function is even, then the point 10, 21/3 also has to be on the function. If we have some function that's odd, then the point 10, -21/3 has to be on the function. If we have some function that is even and contains the point 14, -5, then the point -14, -5 has to be on the function. And if we have the same function that is odd now, so it can't be the same function. We have a function that is odd now, and it contains the point 14, -5, then it also must contain the point -14, 5. Recall that this is the general way to show that something is even. This is the general way to show that something is odd. Next, evaluate the piecewise function. So remember, this is a piecewise function. It contains two pieces, two or more, but two in this case, over specified domains to create a single function. So evaluate it. Pause the video, unpause when you are ready to check your work. Alright, so f of -2. Since x is -2, I'm going to use this piece of the function because this piece exists when x is less than or equal to 0. So I substitute a -2 and I get 1. F of 0, again, I'm still using this piece because this includes 0, so I plug in 0 and I get 5. F of 1, now I'm using this piece, I plug in 1 and I get 1. Alright, here, find the relative extrema and the increasing and decreasing intervals of the following function. Hint, use your calculator. Remember, we went over how to do this. So pause the video, do that, unpause when you are ready to check your work. Okay, so you should end up with a relative minimum at the point 2, -13, a relative maximum at the point -1/3, -2.96, that's rounded, and so then the increasing intervals are -infinity to -1/3, and then 2 to infinity, and then the decreasing interval is -1/3 to 2. If you were confused on how I got that, so I have the function into my calculator here, I put that into y1. I did zoom standard at first, but then I saw that the minimum was below the standard window, so I adjusted my window, and I adjusted it by changing the y minimum to -15. So now I could see the maximum, I could see the minimum, I do second trace, and then I choose minimum and maximum in whatever order you want. I pick the left bound, the right bound, and so on as we did before. You can look at that video again or those notes again in order to see how to use the calculator if you don't remember. Okay, so next one, we have an application problem here. The height y in feet of a baseball thrown by a child is given by the equation below, where x is the horizontal distance in feet from where the ball was thrown. Will the ball fly over the glove of another child 30 feet away, trying to catch the ball 5 feet above the ground? So determine, will the ball fly over the glove, or will the child be able to catch the ball? Pause the video, figure it out, unpause when you are ready to check your understanding of your knowledge. Okay, so we know x is horizontal distance in feet. We know that the child is 30 feet away. So we plug that in for x to find y, because y is the vertical distance, or the height of the ball. And we see that when we plug in 30, the ball is 6 feet high. So, and the kid's trying to catch it at 5 feet. Maybe he jumps, I guess, but assuming he doesn't, or maybe 5 feet the highest he can jump, who knows. The answer to the question would be yes, the ball will fly over the glove because 6 is higher than 5. Exclamation point, because we're excited about it. Okay, so here I want you to graph the following piecewise function and then state the domain, the range, the increasing, decreasing, and constant intervals. Pause the video, unpause when you're ready to check. Okay, so this is what the graph should look like. I color-coded each piece, so the negative 2x plus 1 is the blue piece. The 1 is the green piece, and the x minus 3 quantity squared plus 1 is the red piece. So notice here, at this point 1, negative 1, it is a filled-in circle because that 1 is included in this piece. The green, both ends are open circles because 1 and 3 are not included. However, it does connect right here with the red. So the red has a filled-in circle here, so it's kind of a dot inside of the open circle. And then the red stops here, but does include the point 5, 5. So then what is the domain? Well, the domain is negative infinity to 5, including the 5. Because this is negative infinity to 1, then 1 to 3, and then 3 to 5. 5 is the farthest to the right we go, but we include it. The range is actually just all from the blue piece, because the green and the red are included in the range of negative 1 to infinity. Again, we include the negative 1 because the y value here of negative 1 is included in the function. The increasing interval is 3 to 5. That is this piece here. It is increasing. The decreasing interval is negative infinity to 1. That is the blue piece here. And the constant interval is 1 to 3. It is constant along that interval. Okay, here find all of the zeros of the function and find the domain of the function. You will have to do some algebraic work. Factoring is my big hint. Okay, so here the first thing I did was I factored the numerator into x squared minus 5 times x squared plus 2, and I factored the denominator by grouping. So first I took out an x squared from the first two terms and a 3 from the second two. So then the denominator became x squared plus 3 times the quantity x minus 1. So the black here is fully factored of the function. So now to find the zeros, I set the function equal to 0. X squared minus 5 times x squared plus 2 over x squared plus 3 times x minus 1. The denominator is going to go away when I set this equal to 0, because my next step would have been to multiply both sides by the denominator. So that goes away. So really I end up just setting the numerator equal to 0. Since this is already factored, I can set each individual factor equal to 0. And because it equals 0, remember that's our zero product property. So then x squared minus 5 equals 0 gives me the solutions of x equals plus or minus root 5. Those are real zeros. Those are good answers. X squared plus 2 equals 0 gives me the solutions of x equals plus or minus I root 2. Those are imaginary zeros. I was only looking for real zeros. So these are zeros, but they aren't answers to the question for this particular problem because we only wanted real zeros. Then the domain. Well, remember when we talked about domain, how do we find it analytically? Well, we think about what values don't work. What values won't work in this case would be if I divide by 0. So I set the denominator equal to 0 to find the values that won't work. I've already factored it. So I set my factored denominator equal to 0, set each individual factor equal to 0, and I end up with x equals plus or minus I root 3, which are, those are two answers, which are imaginary numbers, And remember, when we talk about domain, we only talk about real numbers. And then I have x equals 1. So since x equals 1 is a value that will make is a real value that will make the denominator 0, then my domain is everything except for this. So my domain is negative infinity to 1, and then 1 to infinity, not including the 1. Okay, here, state the domain and the range in interval notation. Pause the video, unpause when you're ready to check. Okay, so the domain is negative infinity to negative 5 with a bracket on the negative 5. So this is going to the left forever, so that's the negative infinity, then we move to the right and we stop right here, including that point though. Now there's a gap, so then I start up again here at 1 to this point, and then here, and I go down. Or to the right, I'm sorry, I misspoke. So I'm going to the right. So this, although there's a gap vertically, these do connect. So then it's from 1 to infinity. You will notice on some of these problems, I forget to put this in here, the union symbol. Mathematically, it's a notation thing. It's something you should have there. It's just kind of a detail, but it is understood if you don't have it there as well. So if you don't, it's not wrong. Then range, negative infinity to negative 4. So this piece here, it's going down forever. So that's going to go down negative infinity. And then it stops right here at 4. And now there's a gap. But then it starts up again at this piece, negative 2. And then this increases forever. So it will include this as well. So it's negative 2 to infinity, including the negative 2. Next one, is the following function even, odd, or neither? So I want you to show or demonstrate if this is even, odd, or neither. Pause the video, unpause when you're ready to check your work. Okay, so the answer here is neither. And here I show my work. First, I figured out what is f of negative x. I saw that was not the same as f of x, so it is not even. Then I found negative f of x. I saw that was not the same as f of negative x, so it's not odd. Therefore, by default, it's neither. Alright, last one. Given this is the function f of x, I want you to perform these transformations. 1/2 times the absolute value of f of x, and then minus 2. Pause the video, unpause when you're ready to check your work. Okay, so now remember, with absolute value, we need to pay attention to the turning points, but we also need to pay attention to the x-intercepts, because they could, or they probably will, play an important role. So this point here, I take the absolute value of it, it's still positive. I multiply by 1/2, it goes down to 2, and then I subtract 2, and it goes to 0. This point here, take the absolute value, it's still 0. Multiply by 1/2, the y value is still 0. Then I go down 2. So another thing to emphasize, all of these operations, these transformations here, are affecting the y values of the original function. Nothing is changing with the x values. For this one, I take the absolute value of negative 3, so it becomes positive 3. Then I multiply that by 1/2, and I'm at 1.5. And then I shift down 2, so I'm at negative 1/2. Here, negative 4 becomes positive 4. Multiply by 1/2, it becomes 2. Subtract 2, and it becomes 0. Absolute value of 0 is 0. 1/2 times 0 is 0. Down 2. Here I'm at negative 3, so it becomes positive 3. Multiply by 1/2, it becomes 1.5. And then down 2, and I'm at negative 1/2. That is how we get our solution.